suppose that by using that formula, we have calculated the vertical component of the component, what will be the mass to for that component imbalance forces, vertical forces. So that m we divide into 2, m by 2, m by 2, and then we put it here. So this arrangement is such that when it is rotating at omega, that is the speed, and this will be 2 omega, because second moment is has to be 2 omega because it is 2 theta. So this will be double the speed of the crankshaft engine, and we put it 2 mass. What we actually do, so for an example, this is we have and we have two sprocket which is rotating in opposite direction. If you see the arrangement, it will rotate in opposite direction. Suppose this is rotating in this direction, so this will rotate in this direction. In that case, this will rotate in opposite direction. What we do, we put these two mass, which is m by 2, m by 2, which will, we want to cancel the vertical component, imbalance second moment of vertical component. So for an example, this is rotating in this direction, and this is rotating in this direction. So our mass will be like this. This will be one mass, that is m by 2, and this will be another mass at the same angle in opposite side. So suppose this is the center point and this is the center point. If we have this line, in that case, there what will happen? Centrifugal force will be acting this direction, and will be having a vertical component in this direction, and there will be horizontal component. For these two mass, there will be horizontal component that will be cancelled out because it is opposing each other. And these two component, what will happen? It will add, and it will be this will be the resultant for this vertical component. And if you see this we have kept such a way, this is the same diameter distance, and it will be at the center, so that this at the center means this line. So there will be this resultant force will be acting, this force is acting on this line, and that time our crankshaft will be in this direction. It means the centrifugal force will be in this direction. So there will be a vertical downward force, which is imbalance, which will be balanced by this force. So that will be the secondary or the second moment, order moment. So this vertical force we do cancel, so that engine is up to the second order engine is balanced. So this is the way we balance the second order moment. And first order moment, we put a mass on the sprocket wheel. This is the jockey wheel, which is center line is it is the tensioner wheel. There we keep the same diameter so that it rotating in the opposite direction, but it will be rotating at the same speed of crankshaft. So that is the first moment of inertia. We can balance the first order of the moment, so that the moment, that is the first order of moment compensator, this is the second order of moment compensator. So that is the way the second moment we do balance. And it is the same thing is written. It's so that we get the resultant force. The vertical force is opposing the second moment of vertical force for the engine. This crankshaft is rotating. What will be the second moment? That direction will be opposite, but the magnitude will be same, so that it gets cancelled out. Another thing we need to know that reciprocating forces, it varies in magnitude, but its direction will remain constant because it is on the center line of the cylinder. It will vary, it will move along that line. Whereas centrifugal force is same. Magnitude does not change because we have calculated a fixed mass where we have imaginary mass we have calculated, and that imaginary mass, that formula is good enough to balance the engine. So that we have put it on the crank pin. So that mass is fixed because we have calculated by some formula. So that mass will not change. It means the magnitude will not change because centrifugal force due to that mass, if the radius we have calculated is fixed, and at constant RPM it is rotating, but the direction will change because it is rotating. So direction will change, but the magnitude will remain same. So this is the difference between the reciprocating forces and the centrifugal forces in our engine. So the mass equivalent we calculate, so that much mass we put it in the crank pin. It means when you calculate how much is the mass, it can crank pin that equivalent mass we consider. So accordingly, we divide into m by 2, what we have seen that the 2 sprocket we had for the second moment, and we put there. And that angle has to be correct angle, it should rotate so that the resultant comes, it's sum up and resultant you get, and that is cancelling the imbalance forces. So this the first moment we do it in the jockey wheel, that is the uh, that chain tensioner, but second moment we put 2 jockey wheel where we put the second moment, that is the mass of the second moment, m by 2 m by 2, and then it gets cancelled out. So for the second moment, this is the vertical component of the centrifugal force. Mass equivalent to this is this. So mass of the reciprocating part divided by the 4 multiplied by the connecting rod length and divided by the crank length. From here, we calculate that mass we divide into 2 and we put it into jockey wheel. So twice the speed we have seen, it is rotating twice the speed. That's why we have seen that the force diagram, so it gets cancelled out. So that's the way we make it balance. Now this is the first order I was talking about. This, if you see, this wheel diameter is same, this sprocket diameter, and you have a mass, and how it gets cancelled out. So what will happen? This, suppose the mass is crank pin is here, and that time you have a centrifugal force in this direction, and we have calculated the equivalent mass in the first order, and then that will be having a vertical force, and we can consider this vertical force along this line. So what will happen? This one has to have in, this is, suppose this is rotating in this direction, then what will happen? This is moving this way, so this will rotate in opposite direction. And that time, where will be the mass? Mass will be somewhere here. When the crank pin is here, this mass will be at this angle. And then what will happen? There will be a centrifugal force and there will be a vertical force upward direction. And there will be a horizontal force also. So, but we are balancing in this case, we are balancing the vertical force, because there will be, because of this balancing, there will be a imbalance force, horizontal force, which will be imbalanced. That's why we actually don't completely balance it. Otherwise, this horizontal imbalance force will be high, which we don't want. So in this case, what will happen? This force is upward direction, this force is downward direction, so it will get cancelled out. And when it is rotating, as the crank pin is moving, suppose crank pin is here, then what will happen? This also move in this position, this mass. So this will have a centrifugal force in this direction, this will be the vertical force, and in this case this will be the centrifugal force, this will be the vertical downward direction, and this to get cancelled out. So that is the way the first order gets imbalance forces get cancelled out, and we call it, this is first moment compensator. First order moment compensator and the second order moment compensator is this two. So this is the way we balance it. Now for the chain condition to check, we need to know how what is the checks to be carried out. Yeah, have to tell me.
Chef, can you hear me?
Yeah, I can hear you. Tell me.
Chef, I actually joined the repeating class to because I have doubts in the reversing mechanism of the shaft, the camshaft.
Okay.
If it's okay, I am the only one here.
Yeah, that's okay. So what we'll
If
do,
it's okay,
you tell me the your doubts. I'll clear to that. That's what you want, isn't it?
yes, Chef. The detail of camshaft and reversing servo motor.
You want to know the details of camshaft. Say again. Are you talking about this?
Yes, Chef. That one. Yes.
Yeah, so this is next chapter. I have not actually covered this. This is only I had explained that how actually the arrangement is, because the starting and reversing it is in details. So I can explain you, but the others will be missing because I'll be explaining the same thing again in the next class. Now tell me, I'll explain you a brief, not into that detail, you will understand. But apart from this, any other question? Any
Apart from
other-
this, I think it's okay for me. But this one,
So this one you
last
want
time
to
when
know.
you was
Okay.
camshaft about this angle before 10 degree before TDC and 10 degree when we are reversing the engine.
Yeah.
If it was 10 degree before TDC and when we are reversing, there is a problem, you say. And to overcome this, there was some mechanism to change the fuel cap.
Yeah.
So I was not clear about that one.
Yeah. Let me explain to you. So you are talking about this one, isn't it? So
Yes,
yeah. So let us see this diagram first. So for an example, we have considered, assume that the fuel injection starts at 10 degree before TDC and ends at 10 degree after TDC. Now, for an example, the engine has stopped at 10 degree before TDC. It had stopped at that point. So what will be if you see this diagram, this has stopped just 10 degree before TDC. So this is the uh, TDC is this point. So before the 10 degree before it has stopped. So this angle is vertical line and this angle is 10 degree. Now what will be the position of the cam at this point? We have considered that 10 degree before TDC, it is injection means the fuel injection started. So this is our cam. Cam is rotating in this direction. Our follower will be at this position. Because you can see just from the base circle, it has come to the flank. So just injection has started. It means it will start. It is just on the ramp. So it is 10 degree before TDC. In that case, this will be the position of the cam. Now suppose it means what will happen after that? 10 degree before TDC, it will start injection, and at 10 degree after TDC, it will stop. It means it will start rotating this camshaft, and then at 10 degree after it will reach to TDC. After TDC, 10 degree after TDC, it will stop. Now suppose we reverse it, then what will happen? If we reverse it, then this same from the same position, it means now it was moving in this direction, that's why this position is before TDC. But suppose we rotate in opposite direction, then what is the position? Engine has stopped at this position. It is the 10 degree after TDC, because this side will be the after TDC if you reverse it in this position. Now what will happen here? After TDC, we have considered the injection had stopped. Now we are rotating in opposite direction in this direction. Once we are rotating in this direction, what will happen? This will come to the base circle. And what is that? This point? This point is the, this is the, it means when it was rotating in this direction, this was the outstroke. And this was the return stroke. Now when you are rotating in opposite direction, this is the return stroke, this is the outstroke. Isn't it? Because follower will follow when it is rotating in clockwise direction, follower will move upward direction. It means follower has got a motion. That is the linear motion, vertically it will move up. And here it is vertically. After that it will come to the dowel. There is no displacement, this vertical displacement, then it will move down. But when we are rotating in opposite direction, that time this is the flank which is actually our return stroke, and this is the outstroke, because this will come, this will follow this base circle and then it will come here, then it will have a displacement, vertically upward displacement, and after that it will go to the dowel and it will move down, that is the return stroke. Now this timing is, it means completely out. It means this position, it cannot be here. It means it has ended the injection. Where it should be somewhere here. It means, for an example, fuel pump is not controlling the injection. It means injection end is not controlled by the fuel pump. That is, it is beginning. Beginning is fuel pump is increasing the pressure from this, but end is not controlled by the fuel rack. But actually end is controlled by the fuel rack. But let us consider end is not controlled by the fuel rack. What is happening? Here 10 degree before TDC, for an example, here 10 degree before TDC, then it is moving up and injection takes place. At this point, injection end. Because after that, there will not be any pressure increase. It will be on the dowel. And then pressure will reduce. Then it will further pressure will reduce. At this pressure, it will not inject because there is no further increase of pressure. So in that case, what will happen? This should be starting time, it should be here, end time, it should be here. So then only 10 degree after TDC, it means this is the upstroke. After that, it will go to the dowel and then it will be the return stroke. So if you see, look at this in the reverse direction, if we don't do anything and we reverse it, this timing is completely out. It means it is not the correct timing where this should be here somewhere. And if it is end is controlled by the fuel rack, it will not be at the end, it will be somewhere in between, because fuel rack is controlling, ending the injection. So is it clear what I have told till now? Have to.
Yes, Chef. What I understand is at this point, if the engine has to be reversed, as it is 10 degree after TDC, now it's like 10 degree after TDC, so there must be fuel injection to run the engine at the reverse position. But at the, if we continue like this, the cam is already, uh, there is no injection if we didn't do anything because it's already passed.
See, in this diagram, 10 degree, we have considered 10 degree after TDC, it will end.
Yes,
It has ended here. But what will happen? It will be, timing will be changed because it has to come here and then the injection will start. Here already ended. Okay, which is the 10 degree after TDC. But
yes,
if you look at this is the point when it is coming here, then it is 10 degree before TDC, isn't it?
yes,
Because
yes,
from this point only it will have a displacement, upward displacement. So this is 10 degree of means before TDC, and this is 10 degree after TDC. So is it correct? Because this is the 10 degree before TDC, and then you have the TDC. TDC will be because our injection continue after TDC, 10 degree after TDC. If this is the 10 degree before TDC, it means, and this is the 10 degree after TDC because it will end here. Then what will happen? TDC will be somewhere in between at the midpoint of the flank. So, but we have, this is the, when it has stopped and we reverse it, this was the position 10 degree after TDC. But actually 10 degree after TDC, it means should be here. Have you understood?
yes, yes.
So
That's why in BMW, what I know is they only shifting
roller,
the roller. Yes,
yeah.
I have never worked in Sulzer. That's why a little bit confused.
Yeah. So it is the same thing what BMW is doing and the Sulzer is doing, but Sulzer is turning the cam. Now it is clear to you that the this timing is actually not correct timing if we
Yes,
don't turn the cam in another position, reverse position.
yes, it's clear for me. This one, the one that's not clear is what happens after that. How the cam is rotating. I mean, I'm clear about the BMW, MANE BMW, because they're shifting only the roller.
Yeah,
There is another mechanism. Normally, it was a pneumatic mechanism. I remember only shifting the roller of
yeah,
the fuel injection pump. But here, how is the cam rotating? Because the cam is connecting with the timing of the chain or the gear and crankshaft rotation. So how we?
yeah. Now before we go into that, let me ask you one question which actually last class I had explained to you all. How much will be the turning? How much will turn? This cam has to turn. It means we have realized that if this is the 10 degree before after TDC in reverse direction, this cam has to turn in this direction, isn't it?
Yes,
Then only it will reach there. But how much we turn it? Uh, how many angle? How much angle we turn it? It means, for an example, this is the,
15, 20
yeah,
or
have you
10.
got my question?
Yes, it has to be on the other side because it has to be in the.
Yeah, it will turn, but my question is at what angle?
10 degree.
So uh, let us see this. So how much angle will have to turn? So suppose we have, so this is our base circle and we have a cam. Here is the cam, and suppose our this particular unit is at TDC. So where will be the follower position? So in that case, the follower will be somewhere here, or a little bit we move down. So this is the follower where the engine, when engine is at TDC. It means this is the follower. So we have the vertical motion of the follower in this direction. Why I have drawn here? Why I have not drawn on the dowel? Because
Because still not
yes, absolutely
yet
correct.
started
Yeah.
before, yes, before injection.
So it has to continue injection till the end of the injection, which is 10 degree after TDC you have considered. So now how much angle will be turning? So if we see this angle, this is the position. Now what we'll do, will so for an example, this is so this is the cam, we are turning this angle. So in that case, what will happen? This is the our cam, and our engine is at TDC. It means in reverse direction, engine position we are not changing. So what will happen? The after TDC it has to continue. So that is the reason we have to have the somewhere here. We'll have to, because follower is not shifting. Follower will remain in that position. So only we'll have to turn it so that it is coming to the at TDC. This should be the position, so that this after the from TDC till the uh, dowel, it has to be same position here. So that angle, that much angle has to be turned, so that the we have the at TDC, what will be the position. After that it will continue, because end will vary. So after that there will be, it means for an example, the TDC is at this point, this is TDC. After that it will still move up and then it will come to the door. So this distance has to be same, because it has to continue the injection, and it will keep on continue. It's not necessary it will be 10 degree, it will stop, because depending on the engine load, if engine load is more, it will be more quantity will be injected. It means that can the end can vary. That's the way we control the quantity of injection of the fuel. So it means this much angle we have to turn in reverse direction. Whereas that is the reason it is called lost motion. Now, your doubt is your another, actually you need to know that how it turns actually.
Yes,
So
actually
let me,
here the angle is if it's 10 degree before, now we are changing to 10 degrees after. That means around 20 degrees we are changing the angle.
no, it is not that way. So what we actually, it has to be calculated this way. At TDC, how much, where is the position? And the same position on this side, it is the TDC has to be taken the reference. They take the TDC as a reference. It's not other
Okay,
position.
okay, okay, it's clear because now it's when we see the piston,
Yeah,
it's 10 degree. It's not yet even at TDC, so it's like 10 degree before. So
yeah.
when we are reversing, also we need to calculate that one. How much degree must be 10 degree?
So it will be automatically come TDC. It means if you keep the TDC as a reference, then this will come 10 degree before. We have taken an actually hypothetical values 10 degree. It may not be 10 degree. It may be 12 degree. It may be 13 degree. So this angle, it cannot, see, engine will not change. It is a fixed angle. It will change. That angle of lost motion will not vary, because your advance, it means your beginning of injection and end of injection both can vary actually. So what is been the reference is taken, it is the TDC. At TDC, what is the position? Exactly that position we bring to the, now this was the outstroke and this is the return stroke, but when we are reversing, this is the outstroke and this is the return stroke. In outstroke flank, where the position of TDC is same position we bring, and it has to continue, and that same position once you bring, it will continue, and it will beginning also you can vary, and end also you can vary, because TDC will be the fixed. TDC we are actually not changing. The piston TDC, it will be same, but your beginning can change. Then the piston position is changing, and end also piston position can change, because end you can vary, because depending on the load, how much fuel you inject. So in that case, TDC is one thing. That position, it will continue. Just after TDC it will start, it will reach to TDC and it will continue further. So where is the in ahead position, where is the position of the cam and the follower at TDC, that reference we take, because this can vary. Here we have taken a value of 10, but it might not be 10. It can be different value. And here also end will vary depending on the load, how much it will, where it will cut off. So we take always the reference of TDC, not this 10 and 10, 20, it might not be 20, it can change. But at TDC, it will be same position. After, it means both side you have the allowance. So there's variation you can take. So always it is taken the reference of TDC. If you take the 10 degree and accordingly you calculate and turn, it might not be a help. It means it is always, it has to be fixed then 10 degree after 10 degree before, because will it maintain always same degree end? Depending on the load, your fuel quantity you are increasing. So what will
Yes,
happen?
the injection.
Yes, and beginning also you can change by the VIT. So that's why always it is the TDC position. At that position we bring it at TDC position, and then that is the angle of lost motion. That is the angle we turn. And this turning is fixed because TDC position will not change. Your beginning is changing, end is changing, but TDC will remain same. So that is the reason TDC is always is the reference.
Yes,
Otherwise, you won't be
good
able to
enough.
control the beginning and end. Understood? Clear?
Clear, Chef. Thank you. Now, next one.
And now, how you turn? That is your doubt, isn't it?
Yes.
Let me explain you, but I'll do it again in the next class, because I have not covered that portion. It is there here. So if you look at this diagram, this is one cam. Sulzer uses the one segment of the cam for two unit. That's why if you see one of the diagram, like last chapter, I had shown you one diagram. Uh, I, uh, I opened that before earlier. In that case, two fuel cam is side by side. It means we have this diagram. If you see, this is the fuel cam and we have the exhaust valve cam. So fuel cam is one is for one unit, another is for another unit. Now let us see this diagram. Here, this is the wing which is fixed to the camshaft. Now we are not turning camshaft. We are turning only the cam relative to the camshaft. And we have two cam at the end. And there is a sliding ring. This is the sliding ring which does not rotate. This ring does not rotate. What is happening here? There are three oil. One, this is the inflow, and it can drain, it can pressure line, it can drain. This also, there can be pressure line and the drain. And at the center, there is a signal. Actually, this comes for the signal that it has changed over completely. Now, if you see this too, this is the segment which is turning. And due to this, our cam is turning. So in this case, what will happen? Suppose this arrangement, if you see, this is attached to your camshaft. And we have oil connection both side. It means like today you have seen the rotary vane. We have the chamber and alternate chamber pressure line goes and the alternate chamber drain, it gets drained. Suppose this is here at the middle. For an example, it is here. Then what will happen? One chamber, another chamber, you have four chamber. And this oil connection, there are two connection. Exactly the same way, if you connect one manifold alternate chamber, it means this manifold, if you look at it, it is connected here, this chamber. If you shift this segment here, then what will happen? This is a one chamber. This is connected here. This is next chamber, it is not connected. This is connected in this chamber. We have shift this segment here. Now, what will happen? This is fixed on the camshaft. Now segment will turn. Which way it will turn? Because this side is pressurized, this will move in this direction. And this is pressurized, this will move in this direction, and you have another manifold which is connected here and here, which is getting drained. For an example, this connection is here. You have given the pressure. Other side we have drained. This one. Is it clear? Can you correlate with the what I have covered today's rotary vane? It is same. So what will happen? Camshaft is not
It's clear.
rotating. This is fixed. So the segment will turn because of this pressure. One side pressurized, this is pressurized, this is pressurized, this will drain, this will drain. So it will turn, this segment will take a position, slowly it will move, and then it will take a position of this. It means it will come here and it will take a position of this. So this will be the new position of the segment. And this also other side, what will happen? This will be the new position. So this will be the new position. And this is actually this space will be gap, not this. So this will be here. So this will be like this, because this is straight line and then it is a curve. So this will be a new position. Now, what will happen because of this new position? This segment has turned against the camshaft, and camshaft and this is not turning. So the segment has turned. Once the segment has turned, then what will happen? this segment at the side, this sleeve is attached to, and your cam is on top of the sleeve. And once this is turning, the sleeve also turning, and the cam is turning at the required angle. And this, how much it will turn, it is fixed because it has to come and rest here, that much it has turned. It means, for an example, if you draw a line at the center, and this is the center, so this much it has turned, isn't it? So, like this was here, now this is here. That much angle it has turned. And that angle is fixed. We have taken the reference of the TDC position of all the unit at TDC position. It means how much angle it will turn, that based on that reference it will turn, and it is fixed. You cannot change it. And at the side the sleeve is attached to, and with the sleeve this cam is shunt fitted on the sleeve. So once the sleeve has turned with this, our cam has turned, cam has taken a new position. Suppose it was running in ahead, now it will run in astern position. Is it clear? Have you understood? Have to?
Yes, Chef. The only question that I'm confusing is that means the shaft, I mean cam shaft and the cam, they are not locked together like BMW. Yes or not?
Yes. So that's the reason you have the sleeve, and sleeve and the camshaft, there is a relative motion. It can turn, sleeve can turn on the camshaft, and our cam is interference fit with the sleeve, not with the camshaft. BMW, it is on the camshaft. So that is the reason this arrangement it is. So this is the way we can turn the cam relative to the camshaft. Camshaft does not turn, cam will turn, and this will be the fixed angle cam will turn. But we need to know that whether it has turned or not. Can you see from outside? We cannot see from outside. We'll see that in the when I'll be teaching to everybody. That time we'll see that how we can. We know that yes, it has completely changed. Like BMW, when it is changed, there is a proximity switch on the pneumatic cylinder. So that gives you an indication. When it is astern, it glow the red, and when it is ahead position, when completely it shifts, it gives you a green LED. So by seeing that, you know, yes, it has shifted. But here, there is no pneumatic cylinder and there is no proximity switch. But still, we need to know that yes, it has changed over. Otherwise, your engine might get damaged. If it does not change over completely, your timing will be something else completely. It will not match with the actual timing. So, any other question, Aftu and Lalisa also, and he joined. Till now, what I had taught to you, any question? I mean, any other question?
Yeah, Chef. For me, it's very clear, and I was in doubt before. Now it's very clear because I have never worked in this
Yeah, it is. Once you understand,
cylinder
it is
and
very
expecting
simple.
like this.
You will never forget. You will once the concept is clear. Yeah, good. So, but okay, Lalisa, any question?
Okay. This one, that is clear. But
Yeah,
what about ME engine, which do not have camshaft?
yeah, Lalisa, can you repeat?
For ME engine,
Yeah,
which do not have camshaft,
yeah,
how we can operate for reversing and uh, head and start?
yeah. So ME engine or with Artiflex, they are same, but ME engine slightly different from the Artiflex. ME engine, you have the individual fuel pump. So in individual fuel pump, what is happening? Okay, let me show you one. Yeah, it is there in your syllabus in fuel chapter. So let us see this. So here, what is happening? This is the fuel pump, and it is hydraulically operated. And there is a FIFI ELFI valve. So this is the proportional valve. So what will happen when this gets the signal from the encoder, crank angle indicator. Your engine control unit, it gets the signal from the crank and angle sensor. It gives the signal to the controller, and then controller knows what is the position of the your piston position or the crank angle. What is the position of the crank angle? It is there. So in that case, and that time, this valve will get energized. Once this valve gets energized, then what will happen? There is a supply from the pump. This is a servo pump. Servo pump, it's maintaining a 200 bar pressure. So at the 200 bar pressure, what will happen? This will connect in this direction. So this supply will come and connect to the underside of the piston of the fuel pump. So this is the hydraulic piston, and now the piston will move up. The moment piston is moving up, the pressure is increasing. Like conventional fuel pump, you think that cam is moving the plunger upward direction, then the injection start once the your suction port or the spill port covers. So they maintain the same things, concept. Only thing, instead of cam, they don't have the cam shaft. So there is no cam. So what they do it by the hydraulic pressure. So in the hydraulic pressure, what will happen? This will push the piston. Once the piston is pushed, then the pressure is developed on top, and then injection takes place. And when the end of the injection, because this engine control unit, they measure that how much quantity it has to inject, what is the load of the engine, what is the RPM of the engine. So accordingly it will end, because governor, it is electronic governor is incorporated in the engine control unit for a camless engine. So depending on the angle, what will do, it will start beginning of injection because of the solenoid valve operation. And then this will move up, injection will start, and then once this is de-energized, what will happen? This oil will get drained out. Once the oil gets drained out, this is the drain, and that time this will be connected to the drain. Once this connected to the drain, this will move down and injection will end. Injection will stop. So this is the way the camless engine they use. BMW still uses the pump, whereas Soldier, they don't use the pump. They use the common rail systems for the injection of the fuel. this part actually it's like, so this is the suction valve. So it means when the pressure increases, the suction valve closes, and then the pressure built, and then uh, the injection takes place. It means when it is moving up, at one point the uh, suction valve closes, and then injection takes place. After that, when it is moving down, then what will happen? Moving down when it is de-energized, that time this pressure will be dropped, and immediately the injection will stop. And after that, it will move down, and that the amount it has injected, that amount will compensate again. It will come inside through this suction valve, that inside pressure will be less than the supply oil pressure, and the oil will enter and fill up the top of the piston. It will fill up completely for the, it is ready for the next injection. Is it clear, Lelisa? This will be covered in fuel oil chapter. It is there in your syllabus.
Yeah, it is clear, Chief. But my question is for ME engine,
Yeah.
for reversing system, what kind?
So reversing means, are you talking about the fuel or the air?
No. When we are once we change from air to Aster, same like previous one for Sulzer, we are using camshaft. Yeah.
Yeah.
For ME engine, what system we are using, or it is same?
Yes. So AMI engine for reversing or the ahead astern. So it is angle is sensed by the angle sensor, and that is going to the computer. It is a engine control unit, and engine control unit knows that which unit at, it is the same concept, like for an example, starting, reversing, what we have seen here. So our, the injection of air is 5 degree after TDC and till just before opening of exhaust valve. So the engine control unit, it is getting the position of the crankshaft, crank angle. There is a crank angle sensor which is giving to the computer. It means we have a crank angle sensor. They BMW and Sulzer, they use a different type of sensor. So crank angle sensor, it's giving to the engine control unit. So engine control unit knows they have a program. This crank angle sensor, it's on the one end of the crankshaft. So it referring one unit. Once one unit it is known, then it knows all the unit what is the angle. Any unit within this angle, solenoid valve will energized, and then the air will be injected. It is electronically done. It means there will be solenoid valve. This will give the signal to open the solenoid valve. This gives actually, it gives to the, your individual unit also has got the control unit. So this is the master controller. So it gives the, this crank angle sensor will give you to this, and this will give signal order to the your individual unit control unit, and individual unit control unit then open that particular, it will tell that which particular unit it is in this angle, so the air can be injected. So solenoid valve will open the air, and then air will be injected, and the engine will turn. If you want to reverse it, then it will say, as for the crank angle sensor, which is giving the measured value, it's sent to the ECU, that has to be from here to here. If you want to reverse, suppose this is the clockwise direction, it means this engine is in this diagram, timing diagram. If you see, this is the power stroke, so this is the clockwise direction. So we want to reverse it. In reverse direction, what we need to know? We need to know what is the angle, crank angle of that particular unit. If it some of the unit, usually it is 2 unit at a time it comes. So the moment it is knows that this unit is in this position, so to reverse it, air will be injected, solenoid valve will energized and air will be injected in this unit and it will turn in opposite direction, reverse direction. So there is no distributor separately. Understood? The cylinder air starting valve, which will be operated by a solenoid operated pilot valve. So that pilot valve will give the signal air to operate that cylinder air starting valve. So you don't need distributor for the camless engine. So because this knows, this is giving the measured value where the crank angle is. It means crankshaft individual unit, it has got a program. Once it knows the crank angle, where it is end of the crank angle, it knows where is the all unit, what is the crank angle. And accordingly, depending on the direction you are turning, whether it is ahead or astern, accordingly, if you want to turn it in astern direction, this angle, any unit, this will tell that unit to open the air starting valve. And then that individual unit has got a control unit. This will tell that you open that and then it will open and this engine will turn in this direction. And if it is ahead direction, it knows which unit in this position. It will tell the unit, control unit, that the cylinder control unit, so that cylinder control unit will energize the solenoid valve. That pilot air will operate your cylinder air starting valve. This will be taught to you, but have you understood? Because this reversing and starting reversing, I have just started in the last class, but complete chapter will complete. Is it clear to you, Lelisa? Have you understood?
Yeah, I understand, Chief. Thank you very much.
Because you don't need the camshaft, because it is the computerized computer ECU is giving the command. It knows that where it is. So accordingly, engine will turn in forward ahead direction or astern direction. So any other question, Lelisa?
No, I don't have.
Okay. This you attended last class, Lalisa? Have to attended. You attended or not? Lalisa, you had attended this lecture when I had given in daytime?
Yeah,
Okay.
yeah, I think.
Okay. So if no, and have to, do you have any question?
Jeff, it's clear. Just
Okay.
one more question,
Yeah.
and it will
Tell
be
me.
okay for me. Nevertheless, of the angle, for example, we have discussed about the 10 degree before TDC, so
Yeah.
the cam was changing. What about the other cylinders? The other cylinders has to be changed, yes, nevertheless of the angle.
No, say again. I think you have some, you have mistaken something. So say again your question.
About the when reversing the engine.
That Sulzar you are talking about, correct?
Yes, Sulzer.
Yeah.
Yes, not only one cylinder which is 10 degrees before the TDC. I think the all cylinders, each cylinders has to be changed, yes, accordingly, yes.
Yeah. But why you are talking about 10 degree before TDC? As I told you, it will be TDC will be the reference. Because 10 degree can change, but TDC position will not change.
Yes, I understand. Just all even they are at BDC or the camshaft has to be adjusted accordingly. Yes.
Yeah. So that same angle, it has to be turned in reverse direction for all unit. So what we have actually, this this individual uh, cam for the fuel cam means two cam in pair. So all the unit has got same, and this is the common line. It's connected to this. So individual unit. If you look at this diagram, so we have this is one segment. So it has got two unit. Another segment you have exactly identical two unit. And this connections you have seen, this connection is like there is a common manifold and then parallel connection to all the unit, all the servo motor. So it will turn at the same time when the pressure is coming, it will turn, all the unit will turn. Because all the unit, the angle, lost motion angle will be same. But how much is it? That is the reference for the TDC position reference is taken, how much it will turn. But all unit will turn same because every unit will come to TDC at one point. And it will be before, how many degree before it will start injection, that is also, but individually it can vary. But the TDC will remain same. So angle, this shifting of the cam. So if you see this, that last time what I had drawn, this is the angle, it will be shifted. And that shifting, turning of the cam will be same for all unit. Is it clear? All unit, it will be same or not? If you think individual cam, individual unit, we have seen TDC, we have taken reference and we have turned it, we have bring to TDC, same position of TDC or the cam profile where it was. Now all the unit, it will be same, but other unit will not be at that position at that moment when it is turning. But you'll have to turn that so that when it is coming to TDC, that time that will be the position. So it will not be possible that all unit will come to the TDC at the same time. But you'll have to turn, this angle is fixed for all unit. And this servo motor also is same, all unit. So what will happen? Once the pressure comes, all unit will get pressure and that it will turn in the same direction. And this cam will turn into this angle, fixed angle. That's the reason actually that TDC has been taken the reference. And unless you take the TDC, this angle will not be correct. And this is fixed. We cannot change this angle depending means after it is designed. Once it is designed, after that there is no change. We can see this segment will rest here, that is the end. Move it, this surface will rest here, this surface will rest here, and that is the end. And that is the angle it will turn. This cam will turn. Have you understood or still have some doubt? Have to.
For me, it's loud and clear, Chief. It's all clear.
Yeah, all unit at the same time it will turn like BMW. It turns, shift the roller all unit at the same time. But is it necessary all unit will be in TDC or any other particular position? Same position? It is not same position, but it will shift. When firing order is firing position is coming, it will start firing at the correct angle. So, if no other question, then I mean, I have no problem. If I have question, you ask me, I'll answer to that. But it's up to both of you. Tell me if you have any questions, or if you don't have any question, then we can close it because both of you had attended this lecture already. But it's up to you.
For me, it's clear, Chief, and thank you very much. There was the doubt, and it's already answered, and it's clear, and thank you very much.
Okay, then Lelisa, is it okay or any other doubt?
It is okay. I think better to take rest.
Okay, then we close it here, and good night, both of you.
Okay, thank you, Chief. Good night.
Good night, Jeff. Good night. Thank you.
Good night.